Okay, I think we stop until here, right? The last session. Okay. So this is the question number 12, okay? So this is the electricity chapter, okay? So diagram 12.1 shows a circuit which is used to determine the internal resistance R of a dry cell. So you can see the voltmeter is parallel with the dry cell. Alright, so the first one is, what is the meaning of internal resistance? So internal resistance R means the resistance inside the dry cell here. Okay, so the meaning of the internal resistance is the resistance against the moving charge due to the electrolyte in dry cell. So in chemistry, you learn that you can make a simple dry cell, right? So you know that the negative charge will go to the anode and the positive charge will go to the cathode. So it means there has a charge inside the dry cell. Okay. So the internal resistance is actually the resistance against the moving charge. Okay, inside this dry cell. Okay, due to the electrolyte in the dry cell. Okay, so that's the meaning of internal resistance. Alright, for number 2, okay, so based on diagram 12.1, okay, sketch the expected voltage against current graph and explain how the electromotive force E and the internal resistance R of a dry cell can be determined. So this is different between the graph, the Ohm's law, right? Okay, the Ohm's law, the graph is directly proportional. Okay, so for the internal resistance or the EMF graph, okay, so this is there is a different. So this one is for Ohm's law. Okay, but for the EMF, okay, so the graph will be like this. Okay, decreasing linearly. Okay, so if you want to find, okay, if you uh want to find the EMF, okay, so the EMF is the intercept of the V axis. So here, okay, so this is the value of E. So if you want to find the gradient, okay, so if you want to find the R, the internal resistance, you have to find the gradient of the graph. So the internal resistance for this graph, just find the gradient, and the E value or the EMF value, okay, just find the intercept of the V axis here. Alright. And then the next question is, what happened to the internal resistance R? Okay, if the dry cell is used for a long time. So if the dry cell used a long time, you can feel the dry cell become hot, right? So means the internal resistance inside it means it increases. Okay, so it will increases. Okay, the next one is diagram 12.2. Okay, diagram 12.2. Okay, so shows a circuit consisting 3 resistors. Okay, a dry cell with an electromotive force of 1.5 volts and the internal resistance of 0.5 ohm. So the EMF here is 1.5. Okay, the internal resistance is the small capital R there. Okay, so the first question, find the effective resistance. Okay, so this one you have to solve the R2 and R3 first. Okay, the resistor that arranged in the series. Okay, so R2 plus R3, you got 10 ohm. Okay, then after that, okay, so this already combined. Okay, so it's combined and acting like a single resistor here. Okay, so it will become parallel. So 1 over R, okay, this is the formula for the parallel resistance. So 1 over R plus 1 over R1 plus 1 over R2, right? So 1 over 5 plus 1 over 10. Okay, so you solve it and okay, cross multiply. So you got 3.33. So this is the effective resistance of the circuit, right? Alright, and then the next one is the reading of the voltmeter. Okay, so you know that you need to use the V is equals to IR. Okay, so you have to find V here, right? And then you already have a effective resistance here, the capital letter R. Okay, but you don't know the value of current. So we have to find the value of current first. Okay, so this is the formula for the EMF and the internal resistance. Okay, E is equals to I, okay, R plus R. Okay, so this one, the EMF already given in the equations, 1.5. Okay, I you need to find. So R here is the effective resistance you already count before, 3.33, and then the effective resistance here is 0.5. Okay, so and then you solve it. Okay, you got the I is 0.392. Okay, then you just replace the value inside the formula here. Okay, so you got the value is 1.305 volt. Okay, so that's the answer for this one. Okay, so far, do you have any question? Okay, let's say if you have any question, just open your mic and ask, okay? Because I'm afraid I cannot notice your chat here. Okay, the next one, okay, this one is a portable mini fan used during a hot day. Okay, so this is a characteristic of different mini fan. Okay, so the first one, okay, source of energy use. Okay, whether you want to use the rechargeable dry cell or non-rechargeable dry cell. Okay, and then the arrangement of the batteries. Okay, whether it's parallel or series. Okay, and then the diameter of wire, whether it's thin or thick. Okay, and then the material of blade between plastic or metal. Okay, so the first one, the characteristic. So of course we use the rechargeable dry cell. Okay, long lasting. Okay, or you can say safe cost. Okay, rechargeable dry cell, long lasting or safe cost. Alright, and then the next one, the arrangement of the battery should be in series. Okay, so high effective resistance. Okay, so if you arrange, okay, let's say you arrange the battery, okay, in the parallel, okay, in the parallel circuit like this, okay, the amount of the, okay, the amount of the EMF that you will got, okay, still 1.5. Okay, but if you arrange in series like this, okay, so the amount of the EMF that we got is 3 volts. So that's why we use in the series, arrangement in series, the series. Okay, so high effective EMF. Okay, and then of course this one should be thick diameter of wire because less resistance. Okay, and then plastic material of blade. Okay, so because it's light. So the reason, okay, don't forget to choose, alright. I choose V because, okay, it's rechargeable dry cell. Okay, copy back all the characteristics here. Okay, so this one you got 10 marks. Okay, so finish, discuss paper 2. Okay, and then I give you paper 3, I think like 2 weeks ago. Okay. So I hope you already answer first, okay, before you join this class. Okay. So this is the section A. Okay. So a student carries out an experiment. Okay. Alright. Okay, a student carries out an experiment to investigate the relationship between the length of wire and its resistance. Okay, so the first thing you do, you underline this sentence. Okay, because from this you can get the manipulated and the responding variable. Okay, so underline the variable first. Okay, so between the length of wire and its resistance. So the arrangement of the apparatus is shown in diagram A. An emitter, dry cell, a rheostat, a switch, and a piece of constant wire are connected in series. Okay, so a voltmeter is used to measure the potential difference across the constant wire between P and Q. So this is the circuit. Okay. Alright, and then it says a constant wire of length L 20 cm is connected between P and Q. So when the switch is on, the rheostat is adjusted until the ammeter reading is 0.5. Okay. So this one you know that the constant variable here must be so it said which I V against I, right? So I is 0.5. Okay. So the voltmeter reading V is as shown in diagram B. So you check the value, okay, whether your reading is correct. So this one is 0.4 volt, okay, 0.9 volt, okay, 1.3 volt, 1.7 volt, okay. So check your reading first, and the last one is 2.2. Alright, and then the manipulated variable, okay, so I told you already, you have to underline, okay. So which one is the manipulated, which one is the responding? Of course, the length of the wire will become manipulated, and then the resistance will become the responding, okay. Alright. So the next one is the constant variable. So constant variable, okay, you can put current, okay, or diameter of wire. Okay, remember only to write one answer, okay, because when I mark your paper, some of you put two answer, okay, you cannot do that, okay, must put only one answer, okay, which one you think is the correct one, you put, because you cannot write two answer, it means that you ask me to choose which one is correct, okay, so cannot, only one answer. Okay, and then you have already record the value. Okay, we already read the value of the voltmeter reading. Okay, and then the next one is, okay, so this one you have to calculate the R. So using the formula, R is V divided by 0.5. So this one is actually you can get from the Ohm's law, right? R is equals to V over I. Okay, so the I is the constant one. So we already replace the I value with 0.5. Okay, then you calculate. So this is your answer. Okay, 3.4, 4.4. Okay, and then you have to make sure. Let's say this one is the answer. Let's say the example here. Okay, let's say this one is 1.0. Sorry, only the answer is 1. Okay, but you have to put 1.0. Okay, so the decimal point here will be constant. If you start in only one decimal point, so all of this must be in one decimal point. Okay. So the next one is if you tabulate your result. Okay, so this one is the table. Okay, make sure. Okay, the first mark is actually you must have the LVR here. Okay, means all the column, it has 3 columns: length, voltage, and also resistance. Okay, and then second one must have a unit, right? Must have a unit. Okay, and then the third one, okay, the reading is correct. Okay, the reading is correct. Okay, and then the decimal point is consistent. Okay, means if you already start, the first reading here is 1 decimal point, so all must be in 1 decimal point. Okay, so it must show in the column. Okay, not let's say the one is 0.80. Let's say 0.82 here. So this one you also had 0.00. No. Okay, only for the column. Okay, only for the column. So for each column, if you already put 1 decimal point, 1 decimal point, so all of it must in 1 decimal point. Okay, let's say the R here, okay, the R here, when you calculate, you got 0.833333 like that. Okay, so take 2 or 3 decimal point. Okay, but for this question, if you divide, you got only 1 decimal point, right, using your calculator. Okay, then you just put 1 decimal point. But let's say when you divide, you got like 0.833333 like that. So please take 2 or 3 decimal point. Okay, and then you have to see, alright, for this one, the voltmeter, right? Okay, the voltmeter, if you put 0.40, it's wrong. Why? Okay, because in the voltmeter here, your voltmeter here, the sensitivity is only 0.1. That is the smallest scale, right? You cannot get 0.01 here. Okay, the smallest scale here is 0.1. So means when you when you write the value of the voltmeter, okay, so the smallest scale is only 1 decimal point. Okay, so you have to be careful. So let's say for your meter ruler, the smallest scale is 0.1 cm, right? So means if you write the answer here only in 1 decimal point, okay, because the smallest scale for the meter ruler is 0.1. Okay, so you have to be careful about that. Alright, and then the next one you have to draw the graph. Okay, so I think I draw the graph. Okay, so no, not this one. Hmm, where is the graph? Okay, wait, I show you the graph first. I forgot to scan the graph. Can I show you the graph to you later? Okay, I will send in the group. Okay, so this one increasing linearly. So this one is depend on the graph. Okay, so let's say your graph passing through 0 0, so the answer should be directly proportional. Okay, so mine I think is not passing through 0 0, so the answer is increasing linearly. So I will give the graph later in the group. Okay, the next one is number 2. Okay, so a student carry out an experiment to investigate the relationship between the action of force F and the extension X produced in the spring. So the spring will lengthen when the slotted weight is hung from its lower end. Okay, so the student uses different methods and record the extension X produced in the in the spring. So the student then plots a graph of 4 extension X produced against the force. So the first one, based on the graph X against F, so state the relationship. So we see the graph, okay, so sin is past 0, 0 here, so should be directly proportional. Okay, if you put the answer the higher F, the higher X, so this one is wrong. This one is actually for hypothesis. Okay, so you cannot put this one. When you ask the relationship of the graph, okay, relationship of the graph, the answer must be directly proportional. Okay, increasing linearly or decreasing linearly or inversely proportional. Okay, so that's the only answer that can be accepted. Alright, for number 2, okay, determine the extension of the spring X produced when 4 Newton of the slotted weight is hung at the lower end of the spring. Okay, so show how you determine the extension of the spring and shown on the graph. Okay, so you have to show in your graph, okay, 4 Newton, right? So 4 Newton, okay, so this is 4 Newton, okay, so you underline, okay, until here. So you got 10 cm, right? So the extension is 10 cm. So this one mark. Okay. So 1 mark, and then another 1 mark is when you put the answer here. Okay. So 2 marks. Okay, calculate the gradient. Okay, when you say the gradient, you must have the triangle. Okay, so the size of triangle, okay, so I already put here 5 or 4, or this one 4 or 5. So what is 4, what is 5? So it's count from here. This is count as 1 box, 2 box, 3 box, 4 box. So 4 here, and this one is 1, 2, 3, 4, 5. So mine is 4 times 5. Okay, 4 and 5. Yes, so means the gradient, the triangle is big enough. Okay, but this one is the minimum value. So let's say if you want to make it bigger, okay, like maybe until here, okay, until 5 here. So 1, 2, 3, 4, 5, and then this one 1, 2, 3, 4, 5, 6. Okay, 6 and a half, I think. Okay, so means it's okay. Okay, but this one is the minimum value. So remember when you draw, when you want to find the gradient for paper 3, must have a triangle, and the size of triangle must be whether this one is 4 box, okay, the big box, okay, this one, okay, 4 or 5 box, or this one is 5 or 4 box. This one is a minimum. Let's say you want to make it bigger, then I think it's better than if just follow the minimum one. Okay, but make sure you calculate it is enough lah, 4 or 5 box here, okay. And then the next thing, okay, you know the formula, okay, of the gradient, right? So y2 minus y1, x2 minus x1. Okay, so y2, okay, I take the value 10 and 4. Okay, so 10 minus 0, okay, divide by 4 minus 0, and you got the answer. Okay, and be careful for this one. So many of you, when you calculate, okay, when you calculate, especially the calculation question, you leave the answer in the fraction form. It's wrong, cannot. Okay, physics paper 2 or paper 3, you cannot use fraction as the answer. Okay, so change to the decimal. Okay, don't forget, because when I mark your exercise, okay, the new one, the SPM 2003, most of you, even in your exam, okay, this the diagnostic test, the one that you have to calculate the resistance, right? You leave the answer in the decimal, in the fraction. Okay, no, cannot. Okay, must be in the decimal point. Okay, so this is 3 marks, right? Okay, the first mark, the first marks come from the triangle. Is it, if it big enough, okay, means more, or the minimum is 5, or 5 times 5, like that, right? I told you before. Then you get 1 mark, right? And then the second mark, when you substitute the value, correct? And then before I forgot, okay, before I forgot, there's one thing. Mm, okay, one thing you have to do in your graph. Okay, see, I label the coordinate. Okay, so make sure you label the coordinate. Okay, which one you take for the gradient. Okay, so this one is 0, 0.0. Okay, and I take 4 and 10 here. Okay, so make sure label the coordinate. Then after that, make a triangle. Then after that, substitute in the formula. Okay, and then you calculate, so you got 2.5. Okay, so the second mark come from here. The third mark, okay, is come from the unit of the gradient. Okay, let's say you got 2.5, right? But you didn't put the unit. Okay, or the unit is wrong. Okay, so you cannot get the third marks. Okay, so you must put the unit correctly. So how to put the unit? So this I give you already. Y-axis divided by x-axis unit. So in the question here, you can see the y-axis is cm. The x-axis here is Newton. Okay, so cm divided by n. So that's the unit, or you can put cmn negative 1. So it's same. Okay, so this is the gradient. Alright, the next one is said the spring constant K of the spring, okay, is given by formula F is equals to Kx. Okay, so it say here, using the formula, okay, using the value of the gradient and formula F equals to Kx, calculate the value of K in SI unit. Okay, means you have to change the centimeter here to meter. Okay, so and then okay, actually you know the formula for the F is equals to Kx. Okay, so K is equal to F over X. Okay, so the unit for force is Newton. The unit for X is meter, right? So actually the unit for K is nm negative 1. Okay, but in your unit for the gradient, okay, its opposite, cm over n. Okay, so what you can do, okay, you just divide the k is 1 over m. M is actually the gradient. Okay, so 1 divided by 2.5 because later the cm can go become the cm negative 1. Okay, so this one, and then the unit will be different, right? So the n will be the n negative 1 will become n. Okay, the cm will become cm negative 1. Okay, and then you just change the cm here. Okay, so cm 2.5 divided by 100. Okay, because you want to change to meter here. So 2.5 divided by 100, you got this one. So and then you just divide. So you got the answer 14 Newton meter negative 1. Okay, so that is the value for K. Right, the next one is the elastic potential energy. Okay, can be determined by calculating the area under the graph. So the area under the graph, okay, so it said calculate the elastic potential energy stored by the spring when the force is 2 Newton. So force is 2 Newton is here. Okay, force is 2 Newton is here. Okay, so means you have to find the area under this area under the graph for this triangle. Okay, for this triangle. So half, okay, for this triangle. Okay, so half, okay, multiply by 2, okay, and then this one is 5, right? Okay, but you have to change to meter. Okay, you have to change to meter. So this one, if you don't change also can, but you cannot, later you cannot use the unit joule lah. Okay, and then you have to put the unit NCM. If you want to put the unit joule, you have to change. So this one should be 0.05, right? So you multiply, you got the answer. Okay, but this one, okay, I didn't change. Okay, but the unit, remember, cannot use joule. Okay, if you want to use joule, you have to change the centimeter to meter first. Okay, then you can put the unit joule. Okay, and this one you have to remember, right? Okay, so that is question number, until question number 2. Okay, the experiment. Okay, actually I give you already, I think, the experiment that you need to remember. And for your information, okay, so you can see question number 3 and question number 4. Okay, because some of you did not realize, okay, about this. Right, question number 3, okay, so we see here, this is actually the light, right? Okay, because I have image, water like this. So this is actually the form 4 topic. Okay, and then for this question, right, for this question, okay, minimum current, okay, and then the force, right, force and the minimum current. This one is actually from the electromagnet, force on current carrying conductor. So this one is form 5. Okay, so remember question number 3 is as usually, okay, so far question number 4 is form 4 experiment. Question number 3 is actually from form 4 experiment. Question number 4 is actually form 5 experiment. So you don't need to remember like form 4 and form 5 experiment. Okay, you can just choose one. So whether you want to memorize the form 4 experiment or form 5 experiment. Okay, but I know many of you will choose form 4. Okay, form 5, not seldom, even like any other student also, they don't like to choose form 5 experiment. But the form 5 experiment is actually not so many as form 4 experiment. Okay, but the experiment is not quite familiar, right? Because in form 4, I know you do like 10 experiment, okay, like inertia, all of that. But form 4, I think form 5 means you do only for the resistance, right? And also the wave, okay? And for the resistance, already come out last year, okay? The factor effective resistance, okay? Last year come out the length of the conductor. So I mean, for the factor of resistance to come out again, the possibility is very low lah. Okay, so maybe you can remember like maybe other chapter like wave, okay, or maybe like chapter 8, okay. And then from 4, I think come out already pressure and area. Pressure and area come out last year. Okay, so that one maybe we can no need to remember, and I already take it out from the experiment. Okay, the list the experiment I give you. Okay, so just choose one, whether you want to remember form 4 or form 5. No need to remember all. Okay. Okay, so let's say the answer. Okay, actually this one you can refer from the experiment I give you in the group. Okay, so the first one. Okay, so we see the question first. Okay, so it says here diagram below shows two packed cups, okay, A and B containing different amount of water. A similar coin is placed at the bottom of each cup. So when the coin is observed from the same position, the image of in cup A cannot be seen, but image of the coin in cup B can be seen. Okay, so actually this one is a real depth and apparent depth. Okay, so you already know that these are the two variables here that involve. Okay, so inference. Okay, so inference. Here is the answer. Okay, so inference, I already told you so many times, must have the word depend. This is the keyword depend. Okay, so the apparent depth depend on the real depth. Okay, so you have to know which one is the manipulated and which one is the responding. Okay, so usually the responding variable depend on the manipulated variable. Okay, so apparent depth depend on the real depth. Okay, so the hypothesis, okay, the hypothesis must have the word increase, increase, or increase, decrease. Okay, the relationship. Okay, so if the real depth increase, the apparent depth will also increase. Okay, so that's one is the hypothesis. Okay, sorry. Alright, the aim. So the aim to investigate the relationship between apparent depth and real depth. Okay, let me remind you. Okay, let's say you already start from this is the variable, right? Apparent depth and real depth. Okay, do not change the variable until the last point in your experiment. Okay, because every time you change your variable, okay, you will be penalized, right? So make sure you use, let's say you use the apparent depth. So until the end of the experiment, put apparent depth. Don't change another variable, okay? And I know some of you, this one, let's say the inference, right? Okay, they use the experiment, sorry, they use the variable that they see in the diagram here. Okay, yes, can. Okay, inference and hypothesis, yes, you can use the variable that you see in the diagram. Okay, let's say example. Okay, the first diagram, okay, the first diagram show you the one man uh, pull one box, right? And then the second diagram, one man pull two box. Okay, so let's say in your inference you said that the so and then you see you and then you how can I say this? Okay, and then the question said, okay, the man, okay, feel hard to pull two box compared to one box. Okay, so in the inference you said that the amount of box, sorry, the the hardness to pull the box depend on the amount of box. Okay, that one you can use for inference and hypothesis. Okay, but and then if you come to the experiment, let's say you start from the experiment here, start from aim. Okay, start from aim here. You cannot use box anymore. Okay, that must be already the variable we use in the experiment. So that's why I think, okay, it's better for you, okay, starting from the inference, okay, you already start, okay, using the variable that we use in the experiment. Okay, so in that case, you will just follow until the end. Okay, so the aim is to investigate. Okay, I already tell you. Okay, the variable. Okay, the variable here, the manipulator is the real depth. Okay, the responding is the apparent depth. Okay, and then the constant is density of liquid. Okay, make sure all the variable here. Okay, make sure all the variable here that can be measured. Okay, can be measured in the lab. Okay, so make sure that all the variable that you use, you can measure in the lab, means they have a instrument that we can use to measure, right? Because the real depth, okay, you can using the meter ruler, right? And then the density, okay, you can found, okay, if you use the mass divide by volume, right? Okay, so this one is make sure you can calculate or you can measure using the instrument. Okay, the next one. Okay, the apparatus. So this is the apparatus. Okay, tall beaker, pin, measuring cylinder, okay, meter ruler, water, and method stand. Okay, so all these the material and the apparatus must be complete. Okay, let's say in the experiment in the inertia. Okay, example. Inertia, you use the plasticine, right? Okay, so you must put the instrument that you use to measure the mass, okay, of the plasticine. So you must include the weight balance. Okay. Okay, sorry. Electronic balance, not weight balance. Electronic balance. Okay, so the next one, okay, so this is the diagram. Okay, so the diagram must be labeled, okay, must be labeled, right? And then the next one is the procedure. Okay, so let's say in the exam, right? Maybe because you are nervous, okay, you forgot, right? You forgot the experiment. Okay, so you can remember until the apparatus or material, or maybe you can remember until the variables only. Okay, so this one, if you let's say you don't remember, okay, you already can get like 6 marks from here. Okay, 1, 2, 3, 4, 5, 6. Okay, so you already got 6 marks. Okay, so that's why if you don't know, even you don't know, but you know the variable, okay, you can get 6 marks already. Okay, so this one, put the pin at the base of the beaker. Okay, so hold the other pin, okay, using a red stand. So fill the beaker with the water until the real depth H is 1.10.0 cm. So this is the real depth. Means you put the water until the depth of water become 10. So this one should be the real depth. Okay, and then move the pin, okay, outside the beaker, okay, until, okay, until the P is in line with Q. So you put the pin, okay, put a pin in outside here, okay, and then when you move it, you can see the image of pin, right, inside of the water here. So until the image of P form is in line, same line as the pin O. This one is quite hard to find, okay. So and then the one that you calculate the, and then when you see the pin in the same line as the pin here, the object pin here, so you measure the value of the apparent depth from the surface of the water. Okay, so and then move and then measure the position and using meter ruler and record the reading. Okay, so after you read the responding, after you tell, okay, after you write how to get the responding variable. So this one is said measure the position of P from the surface of water H using a meter ruler. So you already measure, right? Then this word record the reading must have, okay, must have the words record the reading. Okay, let's say if you don't put, you just say measure, okay, using meter ruler. Okay, no words that said that you record the reading. Okay, so means it's wrong. Okay, you lose 1 mark. And then this is the compulsory sentence. This should be the last one. Repeat the experiment by adding more water until real depth H become 15, 20, 25 and 30. Make sure you have at least 5 sets of reading. Okay, so read only one. Okay, 2, 3. Okay, 2, 3, 4, 5. Right? So 1, 2, 3, 4, 5. So this is the minimum, right? They say you want to put until 35, 40 is okay. But the minimum must have like 5 sets of reading. Okay. So this, okay, let's say before this I told you, right, you forgot, okay, you forgot the procedure, right, how the arrangement of the apparatus, okay. But the procedure, okay, you forgot the procedure, but the last one, just write this one. Repeat the experiment with what with all the manipulated variable 5 set. You still can get marks, okay, but you cannot get the 6, 7, 8 marks, okay. Number 6, mark 7, no, 8, no, but number 9, you can still get marks, okay. And then the next one is the table, okay. So the table, okay, so the make sure you have the symbol and the unit, okay, like before question number 1, okay, must have symbol and unit, and put all the manipulated variable here, the value, okay. This one just leave it empty, okay. And then the graph, so this is the graph, make sure you label for each axis, okay. No need to draw the graph inside here, just leave it empty, okay, because we are just planning the experiment, we didn't do yet, right? Okay, so this is how you answer question number 3. Okay, so any questions? Because this one I didn't uh, tell you that much about question, the experiment question, right? How you can get marks, how can you lose marks, right? So I hope maybe after this you'll know. Okay. Actually, this one the experiment not so like the sentence is not like, you know, in your reference book, right? They're quite long, right? So that's why, okay, I make the there, but there's like only a few sentences that you can get marks. So that's why I make that one, the experiment for you, so it's easy for you to memorize. Okay, so just memorize the one that I give you. Okay, so we go to the next questions. Okay, right, the force. Okay. Okay, so you see, so this is the example, right? The inference, okay, the inference, the force on conductor depend on the current. Okay, so the question is this one. Okay, so it's a mixer. Okay, when you set the minimum current, okay, the beater are spinning, but you set the maximum current, it spin faster. Okay, when the beater spin faster, the force exerted on the mixture is greater. Okay, so okay, and then the next one, okay, maybe let's say you don't know what is the experiment, right? There is a clue here giving in the apparatus. Okay, power supply magnets. So which in your chapter you learn from form 4 until form 5, right? So which involve magnet? Of course, the chapter electromagnet. So means the experiment come out from that chapter. Okay, so this is the clue that you can get. Okay, the clue that you can get. What experiment actually this one? Okay, so this one, okay, so the first force on conductor depend on the current. So hypothesis, if the current increase, the force on conductor also increase. Okay, and then you see, starting from aim, I didn't use the word force anymore. Why? Because in the lab, okay, we don't have any apparatus that can measure the force of the copper rod move, right? So means I have to change it to something that I can measure. So you know, if the force is higher, the distance of the copper rod, okay, that move also will be increased, right? So I use the distance, okay, as a symbol of the force. Okay, means Okay, so this one, to investigate the relationship between current and the distant copper rod move. So the manipulated here is the current, okay, and then the responding here, the distant copper rod move. Okay, the constant here is the length of the conductor. Okay, so this is the apparatus. Okay, I copied back, okay, from the questions, and also you have to add some more, okay, some apparatus. Okay, so this is the apparatus. See the meter ruler, because I need to measure the distance, right? So I have to have the meter ruler. Okay, so ammeter, rheostat, and the G clamp. So this is the diagram. Okay, so this is the diagram. Just copy back, okay, and make sure must have a label here. Okay, all right, and then the next one is the procedure. So this one is a very simple one. Okay, the switch on the circuit, okay, or because you use power supply, right? So switch on the power supply. Okay, that one must have. Okay, switch on the power supply. So maybe you can add this one. Okay, switch on the power supply, because this one the diagram doesn't have switch, right? So change to the switch to the power supply. Okay, switch on the power supply. Okay, and then you adjust the rheostat until the current 1.0. Okay, so after the current 1.0, and then you can see the copper rod move. Okay, so you use the meter ruler to uh, measure the distance that the current that the copper rod move. Okay, and then make sure must have the, okay, record the reading. Okay, see every time you measure the responding variable here. Okay, at the end you must say you have record the reading, and you make a notation here. Okay, so distance of copper rod move is actually equal to the force on conductor. Okay, and then repeat the experiment by using current. Okay, so repeat the experiment by using current. Okay, okay, 5 sets of reading, minimum 1, 2, 3, 4, 5. Okay, and then copy back. Okay, copy back all the manipulated variable, make sure has symbol and unit. Okay, so this one is the distance here, D. Okay, see also you have to make a symbol here. Let's say distance of the copper rod move. So it's actually the symbol is D. So you don't need to copy back lah. If not, you have to copy back distance of the copper rod move. Okay, comma D. Okay, that slash cm, right, like that. So because you already make a notation here, change it to symbol. You already explained the symbol D is what. You don't need to copy back. Just use the symbol. Okay, I is the current here. Okay, and then the last one is the graph. Okay, it's the graph. Okay, make sure symbol and unit for each axis. Okay, then the manipulated should be here. The responding should be here. Okay, and just leave it the graph and take. Okay. Alright, so that's the paper 3. Okay, so I hope you are clear, okay, about paper 3. So what you should do, what you cannot do. Okay, so I give you another paper, I think paper 1, right? That one is starting from 2005 until 2019. I think paper 1. I think this one. Okay. Okay. You try to answer. Are you already tried to answer this question? Okay. See. All right. So let's see for the chapter 2, right? Forces and motion. This one is actually 2005 until 2019. Okay. I already put 2019 question. Okay. Alright, we see the diagram 1 shows the path traveled by a car from P to S. Okay, So what is the displacement of the car? So displacement usually in this question, you have to find the shortest distance between P and S. Okay, so the shortest one is here, right? Okay, so what is the displacement from P to S? Okay, use the theorem Pythagoras. Okay, okay, so I close first. Okay, so 5, 3, 1. Okay. 5, 3, 1. Okay, 5, 3, 1. Okay, so the displacement is from here to here, P to S, the shortest distance. Okay, so make a triangle. So this one is 3, right? So for this one, 5 minus 1. So you got this one, 4. Okay, so use the triangle Pythagoras. So this one should be 5. Okay, so the answer is A. Okay, the next one, which physical quantity is equals to displacement divided by time? Okay, so the answer should be B, velocity. If speed, okay, if speed is a distance divided by time. Okay, velocity, displacement divided by time. Okay, the next one is diagram 2. Okay, shows a diagram 2 is a velocity time graph showing the motion of an object. So which of the following describe the motion of the object? Okay, so we make a revision. Okay, first, okay, maybe some of you already forgot. Okay, we have two type of motion graph, right? In the form 4 we learned, right? Two type of motion graph. Okay, so the first one is displacement against time. Okay, sorry for my handwriting. Okay, this one is V against time. Okay, so the graph, so they say the graph is like this. Okay, from the graph displacement against time, alright, the gradient is equals to velocity. Okay, the gradient equals to velocity. Okay, so how you want to find the gradient? You just draw the triangle. Okay, for velocity against time, okay, the gradient is, okay, the gradient is equals to acceleration. Acceleration. Hmm. Hmm. Right. Okay. So and then another thing you can get from the graph of velocity against time is the area under the graph, right? So the area under the graph is equals to the displacement. Okay. The area under the graph is displacement. Okay. So we see first, okay, we see first about displacement against time graph. Okay, there are 4 types, okay, of graph in displacement against time. Okay, the first one is like this. Okay, this first one is like, okay, second one is like this, and then the third one, okay, is like this. Okay, and then the fourth one is like this. Okay, so this is the graph or displacement against time. Okay, there are 4 types. Okay, I told you before that the gradient is actually equals to velocity, right? Okay, so if you want to know the gradient here, okay, the gradient is actually represented by the triangle. Okay, like paper 3 also, right? When you want to find the gradient, you have to draw a triangle. So same like this one. So this one is a displacement against time. So if I draw the triangle here, you can see the size of the triangle is same, right? So mean if the size of triangle is same, the gradient is also same. So means the velocity is same or uniform. Okay, uniform or same. Okay, for this one, can I draw a triangle? No, right? So means the V is 0. Okay, the V is 0, means the object is not moving. Okay, and then for this one, if I draw the triangle, okay, you can see the triangle become smaller. Okay, means the gradient is decrease. So the velocity also decrease. Okay. Okay, for this one, if I draw the triangle, okay, the triangle become bigger. So means the gradient increase, the velocity also increase. Okay, so this is the graph. This is the, let's say you want to interpret the graph. So this is how you interpret the graph for displacement against time to the velocity. Okay, so the second graph is the velocity against time. Okay, so velocity against time. Okay, same also, still got 4 types of graph like this. Okay, but the axis here is velocity against time, velocity against time. Okay, and then you know the gradient is actually represent the acceleration. Okay, same method. Okay, just draw a triangle. So this one, the A is uniform, means uniform acceleration. Okay, so for this one, can I draw a triangle? No, so it means the acceleration is 0. Okay, for this one, the size of triangle decrease, so means the gradient also decrease. So A is decreasing. Okay, and then for this one, you see the size of triangle increase, means A is increase. Okay, so if you want to know the, and then one thing from the graph, okay, for velocity against time, you know the area under the graph is equals to the displacement, right? So this is the area under the graph. Okay, this is the area under the graph. Okay, but for these two graphs, okay, in SPM they will not come up because this one you have to use the integration, okay, in the match, right? So this one will not come out lah in exam to find the displacement. Only the straight line like this. Okay, so this is the graph. Okay, so let's see the question. So and then this one. Okay, so this one, if we draw a graph, okay, so it's like this, right? So the A is uniform. Okay, so the acceleration is uniform, means uniform acceleration. Okay, so B and C is wrong. Okay, and then this one, okay, if you draw a, you should draw a triangle, the gradient still same, right? The gradient still same, so means it's also uniform, but because the velocity decreasing, it is a uniform deceleration. Okay, so the answer should be D. Okay, D. Number 3 is D. Okay, the next one, number 4. Number 4, this one is from acceleration, okay, to the time. Okay, sorry, acceleration to the velocity. Okay, so this one, the acceleration is a negative, right? So mean negative acceleration means there is a, the velocity is decrease. Okay, so which one decrease? This one, the B and or D, right? Okay, for this one, you see the acceleration is 0. Okay, means there is the straight line here. Okay, straight line here. So decrease. Acceleration 0 is decrease. Acceleration is negative, so this one or this one. Okay, and then this one acceleration is negative, so straight line like this. Okay, and then suddenly the acceleration is positive, mean the velocity increase. So the answer should be B, boy. Okay. Alright, number 5. Okay, so this one V is increasing means acceleration, positive. Okay, and then you cannot make a triangle here, so the gradient is 0, so it means 0. Okay, right, and then for this one, okay, it's increasing. Okay, so increasing means going up again, so the answer should be B, boy. Okay, the answer should be B, boy. Okay, the next one, what is the total distance? Okay, so this is graph velocity. Oh, I thought someone want to ask. Okay, so this one is want to find the total distance. Okay, so the total distance from the graph for velocity, you have to find the area under the graph. Is it the any question you want to ask? Okay. So they say if you want to ask the question, just open your mic and ask, okay? Because I will not see the chat. Okay. Alright, for this one, you have to find the area under the graph. Okay. So area under the graph. Okay, this one is a triangle, right? Okay. Triangle. Okay. If you want to, they say you can divide into three. Okay, three parts: triangle, rectangle, and triangle. So if not, it's better to use the trapezium formula. Okay. So at 8 seconds. So the formula for triangle for the trapezium is half. Okay, multiplied by the, okay. So this one 8. Okay, and then this one is 6 minus 2 is 4. So 8 plus 4. Okay, and then the height is 4. Okay, so you got the answer 24. Okay, so the answer should be B, boy. Okay. Okay, the next one, diagram 2 shows a car moving up a hill. The car decelerates as it moves up the hill and accelerates as it moves down the hill. So decelerate means the velocity is decreasing. Okay, and then it says accelerate means the velocity increasing. So the answer should be B, boy. Okay, the next one, you have to find the displacement. Okay, so this is the graph for velocity against time, right? Okay, if you want to find the displacement, you have to take the negative value. Okay, what it means if you want to, if you calculate the area, right, you know that the graph area under the graph, okay, for the velocity against time, we can get displacement. Okay, so you have to take the negative. Okay, when you count. If let's say just want to find distance, just ignore the negative. Okay, so this one, there are one trapezium, one triangle. Okay, so I show you half. Okay, the first one, okay, the first one is half multiplied by 3 plus 2, right? 3 plus 2, okay, and the height is 30. Okay, so 15 multiplied by 5. This one is 75. This is for the trapezium. And then for the triangle, half. So the base here is 2, right? 6 minus 4. Okay, 6 minus 4 is 2. And then the height is negative 30, I think. Okay, so you got negative 30. So take the negative value if you want to find the displacement. Okay, and then after that, just add, okay, 75 plus negative 30. So you got 45. Okay, this is for displacement. They say the question want you to find the distance. Okay, so distance I already said ignore the negative. So there is no negative here. So there is no negative. What is the answer? Should be 105. So if distance, this is the value. Okay, for displacement, this is the value. C is different. Okay, so be careful. Okay, the next one. The diagram shows two students skating towards P. Okay, what will happen to the girl when the boy release her hand? Okay, so means well, where is the direction uh of the girl? Okay, so whether it will stay stationary, move toward P or move toward Q. So of course the answer is move toward P. Alright, the next one. Okay, the diagram shows a pillion rider moving backwards when the motorcycle accelerates. Okay, so the backwards movement of the pillion rider can be explained by, so this one is actually inertia. Okay, so you have to remember sometimes they don't put inertia, they put the first Newton first law. So Newton first law is actually inertia. Okay. Okay, the next one is diagram 3 shows the position of a plate before and after the tablecloth is snatched away. Okay, so the plate remains stationary due to inertia. Okay, so and then this one, a body stays stationary or continues to move at a uniform velocity unless there is an external force that changes its state of motion. So which law is explained by the above statement? Of course, this one is inertia, right? So Newton first law of motion. Newton's second law is F is equal to ma. Okay. Newton's third law means the action reaction. Okay. So it's like let's say okay, when you pull an object on the table, right? So let's say there's table here. Okay. So when you pull the object, okay, you pull the object here, there will be a force that oppose, okay, that oppose the force that you pull. Okay. So this one is called as the frictional force. So this is the Newton's third law of motion, action and reaction. Okay. The next one, okay, this one diagram 4 shows a two trolley P and Q on a frictionless plate. Okay, which of the following statement is true? So you can see there is a plasticine there. Okay, so plasticine means that this is not the elastic collision. This is inelastic collision. Okay, so we make a little revision here. Okay, elastic and inelastic. So elastic collision means, okay, after the object collide, it will move together. Okay, usually in the question they will give you a plasticine there. Okay, so mean after it collide, it will stick together. So this is inelastic. Okay, so inelastic collision. Okay, move together. After it collide, move together. Okay, and then the formula. Okay, this one you have to memorize. Okay. So M1 U1 plus M2 U2, okay, equals to M1 V1 plus M2 V2. Okay, this is for inelastic. For elastic, after it collide, they will move in separate. Okay, so that one, sorry, inelastic is not this one. Sorry, I give you wrong formula. Oh, wait. No. This is not the formula for inelastic. Sorry. Okay, this is formula because they move together, right? Okay. For elastic, they move separately. Okay, so the formula M1 U1 plus M2 U2 equals to M1 V1 plus M2 V2. Okay, so this is formula for elastic. Okay, so see the question here, this is inelastic, so of course A is wrong. Both trolley do not undergo change in momentum. Okay, no, there must be a change in momentum. Right, see the total momentum before and after the collision is same. This one is the principal conservation of momentum, right? So the answer should be C. Okay. The total in the elastic and inelastic collision, there we obey the principle of conservation of momentum. Okay. Even elastic or inelastic, so the total momentum between the total momentum before and after the collision is same. Okay. But for inelastic, okay, the total kinetic energy, okay, before and after the collision is not same. Okay, it's not conserved. Okay, but for elastic collision, the total kinetic energy before and after the collision is same. Okay, so that's the difference, the total kinetic energy. Okay, and then this one, diagram 4 shows two identical balls, okay, P and Q moving towards each other with a velocity V and 2V. Okay, so the collision between two balls is an elastic collision. Okay, so which statement is correct about the elastic collision? Okay, the momentum of ball P before collision is equal to the momentum of ball Q should be before collision. The momentum of ball P before the collision is equal to the momentum of ball Q before the collision. It's wrong because the velocity already different. Okay. The total momentum before the collision is equals to the total momentum after the collision. So this is the answer B. Okay. You must remember, must have the word total. Okay. Total. The total momentum before. Let's say the questions, the answers said the momentum before the collision is equal to the momentum after the collision. This is wrong. Because you know the formula also, it say here this one is a total, right? Because you have to add, okay, the both momentum. So the question, the answer should be the total. Must have the word total. Okay, the next one, okay, the diagram show force F1 and F2 exerted on a wooden block placed on the table surface. The friction between the block and the table surface is 2 Newton. So which pair of forces for F1 and F2 causes the wooden block to move with an acceleration? Okay, so you know if the object want to accelerate, okay, they must the amount of the net force must be bigger than the frictional force. Okay, so the frictional force is 2 Newton, right? So this one, the net force is 7 minus 5, 2 Newton. Okay, it's not enough to for the object to accelerate. Okay, 5 minus 3 also 2. Okay, 6 minus 4 also 2. Okay, 3 minus 2 also 1. So this one, the object cannot move lah. Okay, and then 4 minus 1 is 3. So see, 3 Newton, right? So it's more than 2 Newton. Okay, higher than the frictional force here. So the object will accelerate. So the answer is E. Okay, for diagram 4. Okay, diagram 4 shows a car with a mass of 1000 kg moving with an acceleration of 2 ms negative 2. There is a frictional force of 900 Newton acting on the car. So what is the force exerted by the engine in the car? Okay, so this one when the object want to move, okay, the net force must be bigger than the frictional force. So this is the equation. Okay, so this is the F of the engine. Okay, minus F for the frictional force. Okay, so you will got F net. Okay, net force. Okay, so you want to find the force of the engine, right? Okay, so the question, this one you have to find. Okay, I put FE. Okay, and then the frictional force is 900. Okay. Okay, so how you want to find the F net? So the F net, we use the F equals to MA. Okay, so what is the mass here? The mass here is 1000 kg. The acceleration is 2. So 1000 multiply 2. So you got 2000. Okay, so if you want to find the engine, okay, the force of the engine, so you just add up, we got 2900. So the answer is D donkey. Okay. Okay, for this one. Can you try to answer first, then give me the answer in the chat? Try to answer. What's the answer? Push to the right or push to the left? No answer. B, A. Okay. The answer is B, boy. Okay. So this one, the direction of movement of P, this one actually inertia. Okay. So when the direction of movement is of P is going to the right, right? Okay, then after it hit the Q, so this one will stop. So but it keep insisting, okay, to move, right? So it move to the right. Okay. But this one, okay, since it's stationary, right? So means inertia, it oppose. Okay? Means it doesn't want to move in front. So it will push to the left. Okay? So the answer is B, boy. Okay? Alright, in which situation can the principle of conservation of momentum be applied? Okay, so the answer is D, donkey. Okay, this is the starting block. Okay, okay, so this one we push the runner to the front. Okay, right, for this one, diagram 3 shows the three identical coins P, Q, R at rest on horizontal surface. So what will happen when P collide with Q? Okay, so after P collide with Q, it will still P will stationary. Q also stationary. Okay, but only R will move. Okay, so the answer is B, point. Okay, for this one I already teach you before, but that one you have to find the force, right? The force given by the engine. Okay, but this one you have to find the acceleration. Okay, use the same equation that I gave before. Okay, try to answer first, then give me the answer. Just write in the chat. Okay, good. The answer is D, donkey. Okay, so how you got the answer? Same like this one. Okay, this one is not given by the angel. This one, the one you have to push, right? So means, okay, the force that you push is 10, I think. Okay, 10. Okay, the frictional force is 2. Okay, 10 minus 2. Okay, so you got the F net is 8. Okay, and then use this formula. F is equals to MA, right? So F is 8. Okay, and then the mass is 4. Okay, 4. So you got a 2 ms negative 2. Okay, so the answer should be D, donkey. Okay, this one diagram shows an athlete performing the high jump. Okay, so what is the function of the mattress? So this one, of course, the answer is C, to reduce the impulsive force. Okay, to reduce the impulsive force acting on the athlete when he hits the mattress. Okay, for this one, diagram 2 shows a parachutist landing with his legs bent. Okay, why does the parachutist bend his leg? Okay, so of course to lengthen the time of impact of his feet with the ground. So the answer is A. Okay, for diagram 5.1 and 5.2 shows two methods of the catching ball. Okay, so which of the following explain the magnitude of impulsive force on the hands when catching the ball? So seen here, you can see there is a distance, right? This one is, the distance is much higher than this one. So means the time taken also should be higher. Okay. So you know the formula for impulsive force is mv minus mu divided by t. So if the t increase, the impulsive force will be decreased. The relationship is inversely proportional. So the answer should be, okay, the impulse. So this one should be higher. This one should be smaller. So the answer is C. Okay, and then diagram 2 shows an athlete bending his leg upon landing in a long jump event. So the athlete bent his leg to reduce the impulsive force on his feet. So the answer is B, boy. Okay, for this one, try to calculate. Don't use the formula that I gave just now. This one. Hmm. If you already answer, just put the answer in the chat. Okay, let's try. Okay, B. Okay, so you have to find the F here. Okay, F. Okay, so the mass is 55, right? Okay, 55. Okay, and then the velocity, okay, before touch the ground. So means this is V. Okay, so U means 0. Okay, so 55. Okay, so the velocity here is 12. minus 255, okay, times 0, okay, and the time is 2 seconds, okay. So you got the answer 330. Okay, the answer is B, boy. Okay, correct. Okay, so this is the last one. Okay, these two questions is the last one before we stop. Okay, so what are the front and rear section of a car designed to crumple easily? So this one to increase the impact time. So if you increase the impact time, the impulsive force will be decreased. Okay, so diagram 4 shows a car. Okay, so this one is same like this one, the question. Okay, so the crumple zone is designed to lengthen the collision time. Okay, so this is all about the impulsive force. Okay, so this one we continue next week, right? So I think I stop here first. Okay, so thank you class. So I see you next week. Okay, next week on Saturday, 1:30 to 2:30. So if anything, please let me know early. Okay, let's say you have something like many of you involved in something, tell me earlier. Okay, so thank you.